Good morning and welcome to today's Solid Edge with Synchronous Technology overview. I'm Amy Phipps with Ally PLM Solution, and Kevin Grayson is going to be doing our demo today. He's with Siemens PLM Solutions. We're going to have you guys the mute will not be on, so if you have any questions as we go through the presentation, please feel free to stop us and I just wanted to go over an overview of who Ally PLM Solutions. We are headquartered in Cincinnati, Ohio. We provide design, manufacturing, analysis, and data management solutions for your product development needs. And we provide software training, support, and mentoring for you as well. So what are your barriers to better design? The most common business challenges are getting products to market faster, keeping up with customer demands, reducing design costs, and being able to implement time-saving systems without excessive downtime. So a notable industry consultant, Aberdeen Group, did a survey of companies like yours and found some interesting statistics that tied technical limitations to business challenges. So Aberdeen found that 39% of designers actually struggle with model creation. If you've ever used a traditional 3D CAD tool, you're considering moving to a history-based tool, you've probably been aware of some of the technical challenges that stand in your way. These systems require models to be built in a certain way and use complex rules to preserve shape and size. Aberdeen also found most designers and engineers struggle with the ability to alter existing designs for new uses. Because traditional CAD requires models to build and edit a certain way, making fast, flexible changes often can't be done. In fact, over half of the respondents claim that traditional history-based systems require the original designer to make the change. If you're struggling with keeping up with the customer demands, you're not alone. Responding to customer demands requires the right tools that will let you repurpose existing designs for new uses. If you're trying to cut product cost, reusing existing dating from previous designs, suppliers, customers, or downloaded parts makes perfect sense. However, most half of the history-based 3D users worry about being able to do this. Most 3D CAD systems can import data, but making edits and integrating the parts into an existing design is where the challenge is. Often remodeling is required. Redo generally means wasted money. If you're relying on vendors to make the change, downtime waiting and change fees will not help. If you're looking at cutting costs, make sure that you're able to edit imported data with the same speed and flexibility as if you were native design. And then industry statistics point to an investment in better design tools or methods to manage the design process. That level of change is in most cases why companies are challenged. With meeting their goals, specifically when faced with having to rethink how design is done, if you already have some knowledge of history-based 3D CAD tools, you're probably familiar with what it took to become proficient. Aberdeen reports that over 60% are concerned with that level of change. So Solid Edge, while a complete 2D to 3D CAD solution is different from other systems you may be familiar with. We offer synchronous technology for accelerated design, faster revisions, and better reuse of imported data, and many other areas like production-driven drafting, integrated analysis, and a full suite of products within the Velocity series to help you improve your complete manufacturing process. So I wanted to take a look at synchronous technology. Of the technologies available, we're most familiar with the history-based modeling. They use a feature-based approach for create and edit and generally are dimension-driven, so automating model changes are reliable and predictable. However, achieving any predictability requires a tremendous amount of flexibility in planning out how to edit is going to happen. Any changes outside the planned modification results in a tremendous amount of rework, and we all know the performance issues that this technology suffers from. On the other hand, there are history-free modeling systems, also called explicit modelers. They are featureless and offer little in terms of automated design with dimensions or relationships. that they are fast and flexible and accommodate a wide variety of changes, assuming the proprietary geometry kernel can handle such modifications. So with synchronous technology in Solid Edge, it incorporates the best of both worlds by combining the speed and flexibility of an explicit model and the precise control of parameterized modeling design. That was a mouthful. So Kevin's going to go into the demo of Solid Edge for you and kind of give you an overview of what synchronous can do. Transfer this over to Kevin. Take just a minute. I can see your screen, Kevin. Go ahead.
Okay, great. All right, what we're going to do today is just go through an overview of Solid Edge and talk about the points that Amy had mentioned this morning with being able to accelerate your design, make very fast revisions, and also show you how you can reuse data that you may get from other CAD systems. We're going to be utilizing this motorcycle as the basis of our demonstration this morning. This particular motorcycle is a real motorcycle that was designed from a local community college over in Spain. And what we're going to do today is just show you some of the tools that Amy had mentioned with synchronous technology, working with in the context of the assembly, modeling components, and then also showing how you can create your detailed 2D drawings. What you're going to notice here, Solid Edge has some very extensive rendering tools to create photorealistic images of the models that you create. You'll notice you can get nice things such as reflections. You can also apply realistic textures to your models as well. These can be very handy when you're creating documentation or manuals within your company. What we're going to do today as well is show you how you can work within the context of the assembly. Solid Edge has some really great tools when you're working and you need to be able to display specific components. What I'm going to do right now is just show you the framing components and turn off the other parts that I really don't need to see at this particular time. And this is going to help us in aiding in the design process of modeling the yoke for our front forks. What you're going to notice here is I can go into the context of the assembly to start creating these modeling components. You'll notice that we can display them as a reference, and as I mentioned before, we're going to design the yoke here for the front forks and utilize synchronous technology to do that. What's nice about being able to design in the context of the assembly is we can reference locations of other parts to make sure that we're going to be designing this and make sure it fits in the context of the assembly. So notice how I can reference geometry from these existing components. At any time, I can turn the display off of our components and just focus on the design at hand. 2D users are very used to designing and placing dimensional information on their 2D geometry. I can also not only reference that, but place dimensional information relative to that as well. Notice how utilizing the same dimensioning tool, I can place different types of dimensions. So as an example, I've placed two diameters for the diameters of these locating circles for the mounting holes, but I can also utilize that same dimensioning tool to place locating dimensions. So that's one thing that's very flexible about the system, is not having to select different commands to do the same thing. We'll place one more locating dimension to specify the distance between the two front forks. The other thing too is we can also create additional detail as we're going through and creating additional geometry. So notice as I right click on the screen, I have access to 16 different commands that I use very common. So you'll notice I can access the circular command to place some additional geometry, and then we also can go through very easily and snap that geometry to existing geometry to create additional detail. I'm going to place two more circles on top of our existing geometry, and notice how they'll not only snap down but also create the appropriate dimensional information for that geometry. We'll place some additional elements to help us in the design of our part. Again, as you're creating geometry inside of Solid Edge, you get instant feedback on the screen. So I can tell, for example, when I'm touching other geometry. I can also tell, for example, if I'm tangent or related to other geometry in different ways. So you can see here I'm touching and tangent to the circle, and it just allows for very fast, flexible 2D geometry creation. We'll do one more element here, and again you'll notice how I can snap down to the circle. And what I'm going to do purposely is I'm going to make that tangent to the circle, but I'm going to have the geometry fall off of the circle and not make it precise, and you'll see why I can do that here in a minute with Solid Edge. What I want to do is I want to take this geometry that I just created and mirror it over to the other side. So again, very common tools when you're creating 2D geometry, not only being able to create it, but do things like mirror it over to the other side is something you can do very easily as well. So let me grab that geometry, and we'll mirror it about the XY or the Y plane, or the Y axis, I should say. What we've done with synchronous technology is we've incorporated what we call a region concept. So I've got the 2D geometry created, and what I can do is select the geometry very easily and specify that I want to take this and extrude it some distance. So notice how as I grab the region, even though those lines aren't connected up there at the top, I can just specify that I want to extrude those down 25 millimeters, and Solid Edge will automatically trim that geometry for me. So it's very easy to create, very fast and flexible to create that geometry as well, and get it to do exactly what I want it to do. You'll also notice that the 2D dimensional information that we placed on the geometry automatically connects itself to the 3D model, and you'll see why that's important here in just a few minutes. For now, I'm just going to turn off the display of those dimensions and focus again on my design for the yoke. Again, I want to create some additional geometry. This time I'm going to do it directly on the part. And again, you'll see how we can easily detect where this geometry is relative to other elements. You can see in this case I'm perpendicular to that element. And I also want to go through and just mirror this over to the other side as well. And again, we'll mirror that about the y-axis this way. Again, it creates that region, and what I want to do is take the middle portion of this and just extend it up. Again, I just simply select the region and specify that I want to extrude that up, in this case 30 millimeters. And you can see I'm starting again to create some additional geometry for my design. I want to do a very similar thing on the bottom side, and again I can borrow geometry that exists already just by simply selecting it. So in this case, we'll come up and select the geometry we just created and copy that to the bottom face. And again, that gives me the ability to take that region and either add additional material by moving my mouse cursor down, or if I extend it into the part, notice how Solid Edge will remove that material automatically for me. What's nice too about utilizing synchronous technology is we don't have to concern ourselves with how we've modeled the part up to this point. We have direct interaction with the model. So you'll notice in this case, maybe I want this cut out here on the bottom section of our yoke to be a little bit smaller in width. So I can easily just take the face there and just simply grab it and extrude it in. Maybe I just want to grab it. Notice how on the opposite side it's recognizing that we have symmetry in our model. So I can go ahead and extrude that simultaneously just by simply selecting the face and pushing it over. I can also come in at any point in time and place dimensional information on the part. So maybe in this case I want that to be 25 millimeters. So at any point I can place the dimension on the model directly and have it be the values that I've specified. So we have the basis of our design. Let's go ahead and add some additional detail. Obviously we don't want those sharp rounds. We can go through and just start selecting edges and rounding them to values that we want them to be. In this case we'll make those 10 millimeters. We'll do the same thing here on the outside. And then as opposed to just individually picking edges, I can also pick a chain of edges and have those round as well. And you'll notice how it goes around the entire perimeter of that upper edge. So we've got, again, we've rounded our edges, but and as I look at the part, you'll notice that it's very orthogonal. I might want to add a little bit of taper or a little bit of flash to the part. So what's nice, again, with Solid Edge is I can just grab elements off of the model and utilize this editing tool. You'll notice it looks kind of like a steering wheel. I can grab it and place it at any location on my model and start editing the geometry. So maybe in this case I want to add a little bit of taper to those edges. As I grab just those two single faces, notice how it's going to, again, recognize symmetry with our live rules. So maybe I want to add maybe a 20-degree taper to those walls. And as I look at this too, maybe we have a little bit too much clearance here in the middle. So I may want to take that and maybe make that a little bit less of a clearance there. And I can, again, grab that geometry and just push those faces towards the middle, without having to be concerned, again, with how I modeled that part originally. It gives me direct interaction with the part. Now the other thing too in regards to modeling components is I may want to go through and specify what this is made out of. So Solid Edge comes with an extensive library of materials. So maybe in this case I want to make this out of aluminum. And again, all of the material properties are associated with the list of materials and again, densities, specific heats, all the items that you see listed here are automatically applied to that material, and that's going to help us in detecting things such as weight, things of that nature. You'll also notice that we come with different properties. So if you want to specify specific information about this part, for example, we're calling this the fork yoke, and you can also key in other information such as who the author or the designer is of this component, project information such as document number, revision levels, project names. You can also go through and specify specifically how you want to detect, things such as weights and things of that nature. How do I want to look at this? Maybe I want to detect or calculate the weight of this part in pounds as opposed to kilograms. So you can change any of this information on the fly. Having done that, now we'll go ahead and look at the properties of this part, and you can see at this point we've got a mass of just a little under 2 pounds for this particular part, and that's calculated based on the material specification. That weight is a little bit too high. We might want to go through and remove some of the weight off of this part. So very easily I can tell Solid Edge to get rid of that. I'm just going to select the bottom faces of the part, and I just want to remove all of the internal material. Well, what's also nice about Solid Edge is if you come from another CAD system, you know terminology, and you say to yourself, well, I just want to shell out this particular part. What we have is that when you're working with Solid Edge, if you are familiar with terminology from other CAD systems, you can utilize the terms you're familiar with. Notice at the bottom of the screen I'm typing the word shell. Well, Solid Edge doesn't have a specific command called shell, but it does recognize that terminology and finds the appropriate command inside of Solid Edge. So in this case, it recognizes that I want to do what we call a thin wall. And notice how not only does it find it, but it also executes that command simply by picking on the found command for us, and it does exactly what we want it to do. Having done that as well, I can again see now, having removed that internal material, now that we've got a mass of a part of just over a half of a pound, which is a lot closer to where we want it to be. I'm going to close out and go back to the assembly. We can go ahead and look at how our part is interacting with the rest of the assembly, and we can see we've got some good fit here. Let's look underneath, and as we notice how as we zoom in, we may want to make some changes to our part. And what's nice about Solid Edge is we can do that right from the context of the assembly. So what I may want to do is I may want to extend this internal boss down a little bit. So notice I can grab the face right here from the assembly and go through and just tell Solid Edge I want to extend that down a little bit. And notice I can grab key points off of other geometry. So I'm just going to grab the center point of that upper circle there, and I can modify the part right here from the context of the assembly. Let's zoom up a little bit more on the top level here. You can see in this case our hole might be a little bit too big for the center post here, and I can get information off of other components as well by simply tagging them. And we can see that the diameter of this hole is, or this stem here is about 22 millimeters. And if I select the hole in our part, you can see that that's 28. It's probably a little bit too big. So again, I can modify this part very easily right here from the context of the assembly. We'll go ahead and save this part. And what's also nice about Solid Edge is we have the ability to do simulation. We can specify, is this part really going to work? What's going to happen to this part in normal operating conditions? And what I can do very easily is start doing some simulation or some finite element analysis on this part. So let's go ahead and open up this part by itself. What Solid Edge has is a built-in tool called Solid Edge Simulation. It's going to allow us to do a lot of different work to this part, do the analysis to make sure it's not going to fail out in the field. Before I do that, I'm going to go through and maybe place a couple of chamfers on these upper edges of these holes. So let's grab this upper edge here as well as this one over on this side, and we'll go ahead and add those chamfers there. So as we look again towards the inside, again, now that we've shelled out the material, we might want to check to make sure that this part's not going to fail. So I can do some simulation very easily on this part. So as we look at the part here, you'll notice that we can do a number of different things here as far as applying different types of forces. We can also apply different constraints and then see exactly what type of deflection we might have in the part and see where the critical stresses are going to be. So in this example here, what I may want to do is just create a new study, and Solid Edge has different types of studies that you can specify, whether it's a linear, static, if you want to find the natural frequencies with normal modes, and then we also have some other options here with buckling and steady state heat transfer. We'll go ahead and do just a linear static study in this case, and then you can also specify different types of mesh as well, and again we'll utilize tetrahedral in this case in this example. So again, now that we've defined the geometry, you'll notice that the material conditions come across from Solid Edge into the simulation study, so there's no need to go ahead and reapply what type of material we're utilizing. And then again, we can go through and apply different types of loads. In this case, I'm going to apply a structural load and just apply a force to the outer holes here of our yoke. And in this case, we'll maybe do a 10,000 Newton load. And then we'll also apply some different constraints. So we'll do a fixed constraint here on the center post hole location, and then we'll apply some other constraints. Maybe in this example we'll do a cylindrical constraint on these two outside holes. Up here you'll notice we have other options. If we want that to be free to slide along the axis, we can go ahead and make it fixed or free to slide, and we'll go ahead and apply that as well. So at any point in time you can see the different loads that you've placed on your model. You can also see the different constraints here. And those are also designated with different handles that you can go back in and modify at any point in time. So if I wanted to go in and change the value of the force that I've applied at any point, I can go back in and make modifications to that. I'm going to turn the display of the loads and the constraints off just to clarify, and then I'll just go through and show you how we can not only mesh the model but also have it solve for what we're looking for. The Solid Edge simulation tool utilizes the Nastran constraint solver, which is used by a number of different applications. So it's very reliable. It's going to give you very good results when you're going through and specifying exactly what you're trying to accomplish in your study. So as it goes through and starts to calculate our stresses and our strains and also the deflections that we're looking for, you'll see it's going to automatically give us some good feedback here on the model. Now you'll see here that the deformation is based on a percentage. It's obviously going through and exaggerating the display of what's happening to this part, and we can obviously change that with some settings here. I'll change this from 10% to 2%, make it look a little bit more realistic as to what's happening with the model. So you'll notice here that we can see in our case where the high strains or stresses are located based on our current design. We can also see things such as displacement. You know, how far is this part being deflected with those forces applied to the model. And you can see here the displacement, the higher displacements are here on the outer edges, and if we go back to the stress graph, you can see we've got some stress concentrated here near the hole of our fork hole position. So we may want to go through and make some modifications to eliminate some of these high stress areas. Before we do that though, I'll also show you how you can animate exactly what's happening in your model. So as we go through the animation tool, it'll kind of show you the deflection and the stress areas and where it's coming from initial state to where the force is applied. And you can save out this information. So you can save it out as a movie for communication maybe with a customer or maybe to your sales folks. And you can see a number of other options here, which we'll get to here in just a second. I'm going to close the results, and again, just to show you our high stresses, roughly 294 megapascals, and you can see kind of on the lower end as well where those are, and we might want to eliminate some of that. So what we can do inside of Solid Edge, again, we can go back and make modifications to our design. We have a library here. I have some support ribs that I may want to place inside of my model. So the support ribs is what we call a feature library. It allows us to take different features or elements off of designs that we've created in the past and store them to a library for reuse later. So as I drag those out from the library, I can easily tell Solid Edge where to place those. And again, I'm going to utilize this tool here to place those exactly where I want them. And you can see that we've placed them in. Now what you'll notice here is Solid Edge, the design that these ribs came from, they came from a part which might have been a little bit bigger, but that's okay, because what Solid Edge will allow us to do is utilize those and have them automatically attached to our new design. And notice how those ribs are no longer extending out of the part, but they conform to the geometry of our part as it is today. So it's, again, some nice tools that allow us to reuse features that we've done in the past. Having done that and created the rib structure there, now we can obviously go back in and reapply or remesh the part and do another solve to see if that's helped with our high stress areas and with our deflections in our model. So this will go back through, remesh it to the new geometry, and give us our new results. So again, you'll see the rib structure remeshed here, and you'll also see, hopefully, as we've applied the new rib structure in the interior, how it's going to go through and hopefully eliminate not only the deflection but also the high stress. So here are our new results, and you can see as I flip the model around, the high stress areas are now gone. We went from just under 300 megapascals to 117, so it looks like the changes in our design have helped us in those areas. Now, what's also nice is we can go back through at any point in time and not only make those changes, but we can also go through and also generate report information. And I want that to be 2, not 20. It's a little bit more exaggerated than what I was looking for. But obviously here we've had some built-in reporting tools. What's nice about this is I can specify, again, who the author is, what the name of the report is, and as I generate the report, what Solid Edge will do automatically is it'll capture the information that we've studied so far. So you'll notice it's going through and capturing the information, and then automatically generates a report for us. So as I scroll down through the report, you'll see all the different material conditions, you'll see the load values, and then it also captures pictures from the study so that we can generate a nice report and present those results to whoever our audience is going to be, whether it's our customer or maybe some internal folks within the company. So again, very powerful tools that you can utilize. These are built-in tools in Solid Edge to help you make sure your designs are going to work as you anticipate. So again, we'll go ahead and save what we've done with the part. And what's also nice about Solid Edge is we have the ability to go directly from a part to creating the 2D documentation. So obviously it's nice to have the 3D model, but we also need to generate the documentation, the manufacturing information for how this part's going to be created. So right here from our directly from our part, we can go through and tell the system, let's go ahead and create a drawing. What Solid Edge utilizes is the ability to have what we call quick sheet templates. And a quick sheet template could be simply a drawing template with predefined views. And if you know, for example, that I want to document my part models with a front view, a top view, an isometric view, and maybe a section cut, you can predefine those templates. And essentially, when you go to create the drawing, those views will already be specified in your model. The other nice thing about creating a quick sheet template is you can also have it extract automatically for you any dimensional information that was specified in your model. So it not only does it create the 2D drawing views, but also notice how it extracts all the information that we already applied to the 3D model. Again, that's going to eliminate redundant work with having to apply those dimensions here in the 2D drawing. Now, as an example, if you need to add some additional dimensions, that's okay, because we utilize the same dimensioning tools here in the 2D drawing that we used inside of the 3D model. So again, from a usability standpoint, you're not learning different tools or new tools for dimensioning purposes. I can still come in here and specify, for example, what is the radius of this outside edge here, or if I want to specify maybe the angle of this part, I can do that also. And we'll show you that here in just a second. I want to create some additional views. Maybe I want to get a little bit more detail for some of the rib structure up here. So what I may want to do is create an auxiliary view. And you'll notice just by simply snapping that auxiliary line down to the model and pulling the model up, it'll create that auxiliary view for us automatically. I may not need to see the entire view. We also have the ability to go through and crop the view and just show exactly what we want to see. And then again, I can move that to any area of my drawing sheet and place it exactly where I want it. Here from the auxiliary view, I can also again place some of these additional dimensions. Again, utilizing the same dimensioning tool we looked at earlier, maybe I want to generate what the angle of this edge is here, or maybe get some other information relative here from this section view. Maybe I want to specify what the rib thickness is or the thin wall is. So again, I can come in and just simply grab the elements themselves and have Solid Edge generate that dimension for me. You'll also notice that Solid Edge will extract the property information that we saw from the model. So it can automatically fill out your title block. And in this case, it extracts out the title, the drawing number, and you can also have it extract out any piece of information that you've applied for that particular part. Detail views are also very easy to create. I simply just create a circle on a drawing view, and then it automatically will blow that view up and scale it up or down based on the detail that we're trying to get. The detail circle is also very dynamic, so if I need to move it to any other portion of the drawing view, you'll notice that the detail view over here will automatically update for us. And again, if we need to place some dimensional information or get some different detail out of the part, we can do that here as well. So creating drawings inside of Solid Edge is very easy to do. Everything is connected back to the 3D model, so if we made any dimensional changes or design changes to the model itself, that would automatically be reflected in the drawing as well. We'll come back and do some additional work in the 2D drawing a little bit later. What I want to show you now is the ability to go through and reuse data that you may be getting from a customer or a supplier, which may not be of Solid Edge format. So again, I want to show you directly from the File Open menu how Solid Edge is capable of reading in data from other CAD systems. As you look here towards the top of the list, we have Solid Edge native files, and then you'll also notice that we bring in files from other systems. From a 2D perspective, if you have AutoCAD files today or you get AutoCAD files from a customer or a supplier, we can open those up directly. And as we move down the list, you'll see some other recognizable CAD formats such as Inventor, Pro-E, SolidWorks, and we can open up those files directly as well. The example I want to show you is opening up a SolidWorks part file. And where this comes from is we have a supplier that we use for our design. It's basically going to be a linkage to our swing arm here in the back. And what I want to do is I want to open up the file that's been provided to me, and I want to show you some tools that Solid Edge has that's going to allow you to work with that data. So again, we're bringing in a non-native Solid Edge file. This is coming from SolidWorks. And I want to go ahead and open that up and just again show you some ideas and some tools that we have that's going to allow you to work with this data. So unlike native Solid Edge files, which has a feature recipe here on the left-hand side, when you import data in from other CAD systems, you're left with just what we call a body or a part copy, and it's basically a mixture of all of the different features that came from that CAD system. We do not have the specific features such as the holes or the protrusions. We basically just have one big chunk of material. And you'll notice that Solid Edge has some tools available that's going to allow us to work with the data. The first thing I want to point out is you'll notice that we have these counterbore holes. And Solid Edge has some different tools that are going to allow us to recognize the data from that geometry. So again, as I go to our tool called Hole Recognition, again, Solid Edge is going to say, okay, I recognize these to be counterbore holes. Maybe for my purposes, I don't need them to be counterbore holes. Maybe I just need them to be simple holes. So I can very easily go through and tell Solid Edge to change them from counterbore holes to simple holes with a different diameter. And as I do that, you'll notice how the geometry automatically updates for us. The other thing that I may want to do with this part is, I don't have the individual features, but I can still manipulate it with common things such as placing a dimension on the model. This is one thing that Solid Edge has that other CAD systems don't give you the ability to do, is to place dimensions directly on the model. And in this case, I want to place the distance between those two holes. I can place that dimensional information directly on the model and then make modifications to the part. So one way that I can do that is I can simply select the geometry, and I can utilize, again, our editing tool here to do something like a stretch. If you're coming from a 2D world, you're probably familiar with being able to stretch geometry on a drawing. I can do that same type of application here inside of the 3D world. So notice I just grabbed the outside portion of the model and I can stretch it. So maybe I want to stretch this 10 millimeters and make this a little bit longer. Or I can also do the same thing by changing the dimensional information. So right now this is an 85 millimeter dimension. Maybe I want to change this from 85 to 72. So I can make that change either directly with stretching or by placing or changing the dimensional information. So again, notice how as I change that dimension from 85 to 72, it'll go through and not only it'll take it and make it shorter for us. I may want to place some other dimensions on the model for some critical information. Maybe I want to specify what the width of these ears are. Again, I can just grab the edge information, and maybe I want those to be 9 millimeters. So again, I can place the dimension on there. I can also place a dimension to specify what the width of the between the two ears is as well. So maybe in this case, maybe want to go from 40 millimeters, let's say, to 50 millimeters. Make this a little bit wider. Some other things that we have the ability to do as well is recognize other types of features besides holes. I can come in as well and grab a face. Now what I want to do in this case is I want to take away this internal cutout. I want to add a little bit more strength to the part by adding that material back in. And what Solid Edge allows us to do is recognize that that is a cutout. And I can simply just delete that feature, and you'll see how it adds that material back in. Even though I don't have that cutout feature right here on the left-hand side, I can still make modifications to it. The other thing I can do is, again, maybe I want to make this a little bit thicker. So again, I can come in and grab different information. Maybe I want to grab all these faces here and just extend those up a little bit. So again, utilizing our editing tool, I can just simply tell it, let's move those faces up a couple of millimeters. Make that a little bit thicker. It's going to make it a little bit stronger for us. So again, the point that I want to make is even if you get in data from other CAD systems, you still have the ability not only to read it in, but you can also make changes to it to suit the needs that you need for your application. We'll go ahead and save this as well. Let's designate this as a Solid Edge file and give it a name. And then we'll come back out and show how we can use that inside of our design. So we'll go ahead and close this file. We'll come back out here to our assembly. And just to show you how easy it is to place parts into the assembly, you'll notice that we utilize a library technique. So I go to my parts library and I can find the part that we just brought in from SolidWorks. I can drag it in from the library and then just start constraining it to other components. In this case, I want to take this face and tell it to mate up to this other face on our other component, and it'll snap automatically for us. And then I also want to make sure, obviously, that the holes are lined up. So we'll go ahead and have it align the holes as well. What's also nice is I can dynamically move components as well, just by simply dragging them or rotating them along an axis. Maybe I want to push this part back, and it's, again, as though I'm putting my hand on that part, I can just go ahead and grab it and move it as well. So again, this is an example of bringing in foreign geometry from a 3D CAD system. Well, what about a 2D CAD system? So I'm going to show you another example of how you can utilize existing 2D information as well. I have another component here which I need to connect the part that we just brought in to our shock absorber. So I want to go through and we have an existing 2D drawing of that part, but I want to create it as a 3D model. So again, I can come in and specify that I want to open up an AutoCAD file. And this time we'll utilize a DWG file as the example. And again, what's nice about Solid Edge is we bring in this 2D information. The layer structure is going to come across automatically for us. So again, if I needed to hide a layer or change anything about that layer, I can do that. Maybe in my example, I don't need to concern myself or see the border or the center line, so I can come through and hide those. But again, the point is we can bring in the same layer structure which was in the original AutoCAD file and bring it directly into Solid Edge. Now in this case, we have two different views of this part, and we have a tool inside of Solid Edge built in called Create 3D. And what Create 3D allows us to do is to go through and create a 3D model from this 2D drawing. We also can bring in and utilize the existing dimensional information. So obviously, whoever designed this part, it gave the critical manufacturing dimensions and information, and Solid Edge is going to allow us to utilize those dimensions. So again, what I'm going to do is I'm just going to select the views off of our drawing. And what Solid Edge will do for us automatically is it'll take that information, copy and paste it automatically for us into a 3D modeling environment. So it lines the views up for us. It brings over the existing dimensional information, and what I can do with that is utilize it for my purposes in generating the 3D model. So what I'm going to do is, again, I'm going to utilize synchronous technology to grab regional information. So we'll grab these three outer edges here, which are going to represent the outer boundaries, and we'll extend those to their thickness. And we can utilize the other view as a reference for us. We'll do the same thing by grabbing the bosses. So we'll grab these three bosses and extrude those out the appropriate thickness. And again, we can utilize the other view as our reference. And then in terms of the internal material, again, I can go through and specify that I want to reference that as well. So again, I can grab that. And this time, if it's, as opposed to selecting the other view, I can also type in that value. You'll notice that I have the dimension up here that came from the drawing. I know that that's supposed to be 10 millimeters, so I can simply type that in. And what I want to draw your attention to is notice how Solid Edge automatically brings the 2D dimensional information and automatically attaches it to our model. And the benefit of that is I don't have to dimension that manually, but I can still utilize this information to make changes to the part. I may want to go through and place some rounds and some chamfers on this part. Again, I have that same information here. So maybe I want to round all of the edges of my part, and we'll make that, let's say, 1 millimeter. But also, I don't want to round the internal holes here. So again, I can go through and say, let's go ahead and remove those. We'll put a chamfer on those instead. So I can remove those and just round all the other edges. And then we'll also come in with the chamfer in this case, and we'll just grab the whole information. So I can grab all of those faces and apply that chamfer automatically. So again, I've created some design intent here. The other thing I may want to do is make this part a little bit longer. So again, what's nice about Solid Edge is I can stretch this information out and I can make this exactly what I want it to be. But what I want to draw your attention to is notice how our ribs are changing thickness here. And again, we have some tools built into Solid Edge that's going to allow us to make sure that we can make those changes very easily. So I'm going to come back here and tell Solid Edge that, well, I want to add some of my own design intent. Again, this came from an AutoCAD drawing, and as I'm creating the 3D model, I may want to go through and specify what this rib thickness should be maintained to be. So we have tools that allow us to do that very easily. So I'm simply going to select those ribs and just tell it I always want them to be 4 millimeters from that outside face. So I can apply that in. I'll do the same thing for the rib structure up here at the top. And that's going to automatically build that design intent here. You'll see over here on the left-hand side, we've built in those relationships. So what's nice about this is if I needed to go through now and make some of those changes, I can do that very easily. So if I want to stretch this up a little bit, make it a little bit taller, notice how the rib structure maintains its thickness there. So I can either stretch it up this way, or again, if I want to utilize the dimensional information to do that, I can do that as well. So maybe I want to go from 60 millimeters, let's say maybe to 75 millimeters. And then we'll make a couple of other dimensional changes as well. So again, you can see how you have a lot of flexibility here in making those changes to your model. The other thing you can do is if you have a dimension that's critical, you can lock it. So if you want to lock it to a specific value as you're making changes to other dimensions, you have the ability to do that as well. So very flexible in placing any dimensions that you need. We'll go ahead and save this as well to our library. I also need to place some additional components, some bearings here into these holes. So what's nice too is we saw before where we can go and create a drawing right from the model. We can also create an assembly file right from the model as well. So again, if we go back to our parts library, I have some components here that I need to place inside. And again, just to show you how easy it is to place components inside of the assembly, I simply drag the part in and tell it exactly where I need it to go. Once we have one of these in the assembly already, as opposed to going back to the library, I can now just drag it in from our left-hand pathfinder and place a new one. And then one other way of doing the same thing is we can also just copy that information as well. So you'll notice I'm going to take the one down here that I placed at the bottom, and then just by simply holding the control key down on my keyboard, I can go ahead and copy that up to the top hole. So many different ways of doing the same thing. So we've placed those in. We need the same components on the opposite side. And again, as opposed to placing them in 3 separate times, we can also go through and mirror components as well. So I'm going to go through and select the 3 that I've placed already. Specify where I want to mirror them. In this case, I want to mirror them about the center of the part. And then you'll see how Solid Edge will automatically come in and show you all the different components. In this case, as opposed to it being a mirror, I just want to rotate those over to the other side. And Solid Edge will add the additional bearings for us. So again, we'll go ahead and save this. And then again, we'll utilize these components which came from AutoCAD as we generated these parts very easily. And we'll go through and utilize those inside of our design. We'll go ahead and close the drawing as well. So as we come back to our motorcycle, we want to go ahead and grab these components and utilize them in our design. So again, we'll come back to our library and grab the assembly we just created. And again, we'll just drag that in and constrain these parts. So again, very simply, just grab the geometry and specify where you want it to go. You'll also notice that we can place in different conditions for our assembly relationships. If I want to mate faces but also include some type of offset, I can type that value in right up front. And maybe I want to take and make sure that this face is 3 millimeters from this inside face. So we can have it positioned exactly where we want it. I may want to come in and add some additional relationships to this. So you can see that we can come in very easily and maybe apply it to other components as well. So we'll take the cylinder here and line it up with our hole off of our other component. Notice how Solid Edge is flexible. It'll move the components exactly where they need to be. So that we've got a nice fit there for our rear suspension. The last thing I want to show you here in terms of the assembly is what we call fastener systems. Obviously, we need to connect these components together. So I want to come in and show you some of the built-in tools that we have for standard components such as nuts and bolts and how we can link these parts together. So what Solid Edge was going to do is it'll prompt us where do we want to place fasteners. And again, I'm just going to select that hole there. Notice how it finds the other hole for us automatically. And then we'll go ahead and find the opposite side. We want it to go and extend all the way through this end. What Solid Edge will do as we specify the holes that we want to place fasteners in is it'll find for us components that will fit inside of that size hole. So we can pick from a standard group of socket heads, cap screws, or if we want to grab another type of screw or bolt here, we have a list of components here and we select the one that we want. We can also go through and specify other information such as washers and bolts for either the top stack or the bottom stack of our fastener system. Once you've selected the components that you want, you can also go through and save the ones that you've selected. So if I've selected, for example, a cap screw and maybe a hexagon nut for the bottom side, and we know that we're going to use that in the future, we can go ahead and save those settings so that we don't have to pick them from our list every single time. So as we select those, you'll notice that Solid Edge will go through and place those components exactly where we told it to. And then just to wrap up, we'll come back to our drawing and just show you some other items that we have available inside of the drawing. So I'll go to a second sheet here, and again we have capabilities of placing exploded drawing views, and we may want to get some other information out from the part inside of a parts list or a bill of materials. So we have the ability to very easily just tag the view that we'd like and specify information that we want to call out. So I want to get all the information off of the motorcycle chassis, and again with a couple clicks of the button, what Solid Edge will do for you is it'll automatically balloon all of the components and then also generate a nice parts list where you can get information such as item number, the title of the components, document numbers, and then also quantities. This list here is customizable. You can call out any information that you want. Also, if we want to check the stroke of our components here, specifically with the back side of our motorcycle chassis, if we want to go through and check the rear suspension and kind of the travel that you have as it goes up and down as you maybe hit bumps in the road, we can also do that as well. So you'll notice here if I grab a drawing view, we can also specify that we want to see different views of the same components. So you'll notice here that I have an option here, what is the full height, and then what is the bottom height, and we can set up different views to be displayed simultaneously. So again, you'll notice that the first or the primary view will be displayed in one setting, and then you can see other views here showing you the bottom height. And again, you can get information between the two views. So for example, if I wanted to see the distance between the two heights here, I can grab that information and see what that distance is between the two views. Or if we go back here to the back side of the wheel, we can detect things such as angles. So maybe we'll come here and see what the angle is between the full height and the bottom height. And again, we'll grab that upper edge here. Let me zoom in just a little bit. So we'll grab that upper edge on the one view and grab the top edge of the other view, and we can see that that is a 9-degree difference between those two. Finally, just to show you some built-in tools that are going to be very handy for you as a new user, Solid Edge does have different help tools. We do have a specific help menu for AutoCAD users, so if you are coming from an AutoCAD background, this menu will help you and streamline your knowledge into Solid Edge, utilizing AutoCAD terminology and help you get up to speed from a 2D perspective. We also have built-in tutorials, which will teach you how to use Solid Edge right out of the box. So as you go to the tutorials, what Solid Edge will do is it'll bring up a number of different options here for learning how to model components, modeling parts individually, or if you want to learn how to build your assemblies or create your 2D documentation. We have roughly 25 to 30 tutorials that are built into the software that will teach you how to use Solid Edge right out of the box. With that, I'll turn it back over to Amy, and we'll go ahead and wrap up the session for today.
Thanks, Kevin. That was a great presentation.